Hey guys, in this video I want to talk about adding C++ functionality to your FEMAP API scripts. Now a lot of us have programmed in the FEMAP API window might have noticed that there's a bit of a limit when we come to looping in Visual Basic. This is specifically a FEMAP WinWrap basic, but the virtual machine that it runs through is the same. The code here is interpreted, so clicking play on this short program, you see it takes about 11 seconds. We can see that for loop here is really the only main thing that's going through. But if I use something called fast loop, which is a precompiled C++ DLL that I've done ahead of this video, we can see that I can dramatically increase my time here. I'll explain some of these parameters in a second, but I'm just going to fill this out so that I have my entry as an array and the upper bound of my array going into this fast loop. And we don't want to affect our time, so let's comment out the Visual Basic style, and then we'll run this again. And wow, that's pretty incredible. We can see almost a 55 times improvement in the amount of speed in our program. So how did I do this? Well, first thing you're going to do is open up Visual Studio or Visual Studio Code, whatever you have to compile code, and we're going to make a C++ DLL. So I've done this ahead of time, but we're going to use the exact same process, and we're going to create a new version of this. I'm going to call it fast loop example, fast loop EX. So let's create this new fast loop. Visual Studio fires up, and we can see that we have a C++ file here. We've got source files, Solution Explorer. We have some boilerplate code here that's created in DLL main. We can just get rid of some of this. We don't need some of this API entry. We're going to export only one function from this, which is our fast loop. So let's just jump in. First thing I'm going to do is add something called the atlsafe.h. This is a header that describes the active template library. So this lets me use wrapped calls like ccom variant and ccom safe array. And I'm going to put this into this program here because we'll see how I can transfer data really easily. So we're going to do a std call. That's the Win32 method of calling the system. We're going to do a function called fastloop.ex. And we can see our two entries here just like we typed in the already precompiled one. So right here we're going to declare a local variable that's the local upper bound. This is going to localize our value coming in from this pointer of ubound. And then like I said, the ATL library lets me use ccom safe array. That's a templatized class, so I'm going to use the template parameter double here because I want to return calculations of doubles, basically with decimal points. And I've dimensioned that to have local UB plus 1, so we'll see why. The SA_XYZ array, it seems like it needs a value upper bound of 1 plus whatever a 0 array in C++ would normally be, but normally C++ arrays are 0 bound. So we're going to dimension that, and we're going to put this inside of our for loop. So we've gone from I equals 0 to less than or equal to the local upper bound, and we're going to increment by 1 each time. So in the similar way that we did our loop in FEMAP, we're going to do our loop here with 1.2 times the value in node XYZ. Now, importantly, we can see here node XYZ of I is being used directly, but there's really nothing indicating that this is an array. And we'll see that the client is responsible for calling this properly. The person using the FEMAP DLL is going to need to do this. I'm changing the release and the debug information here to x64 because we want to build a 64-bit program. And one of the last steps I have to do is include a definition file. So a module definition file tells our linker how to look and export this function. So some very simple parameters here. We are creating a library called fastloop. We are going to export the fastloop.ex example function that we've created. So I'm going to copy that from here. We called it fastloop big X. Of course, case sensitivity is important here in C++. If I open up my properties, I'm going to go right to my linker, and I'm going to jump to input. And right under module definition file, I'm going to flatly type out the module name that I've given it, which is defile.def. I can say OK. And so I've done everything I need to now in this program to build and run my solution. Now, a DLL does not run from Visual Studio unless you link it to some other process that needs to load that DLL in. So we've succeeded, which means we should now be able to load this into FEMAP. Let's go grab it from the file that was just built. I'm going to open my containing folder, go to x64, my release. I'm going to just right-click holding shift and click copy as path. If I come back into FEMAP, this code is exactly what I want it to be, so I'm just going to replace what I already did with one we just did live. And we're going to navigate to that fast loop, and we're going to just change the name to fast loop EX, and then we're going to go down to fast loop and call that the proper name. So if we run this again, boom, we've got a super fast program that's doing calculations on all of the nodes in this model. Thanks for watching.